Okay, so if you're watching this video, it means that you watched the last video and you know why these formulas are up here at the top of my paper right now, okay? Because the last video told all about how all three of these were formulas for cosine, sine, tangent, secant, cosecant, and cotangent. Now, what this video is actually going to be about is practicing using these trig functions and deciding when is the best time to use the formulas that you see. It gets confusing because there's so many choices, you're not sure when to do what. The first thing I want to do is talk about this column right here, okay? And this is the adjacent and hypotenuse and opposite and blah, blah, blah. The time that I would use these formulas is if somebody had given me, for example, if they had said, given that the tangent is equal to 5 over 6, find the other 5 trig functions. So notice it doesn't say find the angle, okay? If it said find the angle, we could pick up a calculator, but it doesn't want that. It wants the ratios or the formulas for all the other 5. Now, if I am given something like this, what I look at is I look at these two numbers, and if these two numbers don't look familiar from my points on the unit circle, then I know the easiest way is to draw a triangle. And by the way, what I'm showing you will work even if those were unit circle values. So this might be the easiest method of all if you're getting caught up and tripped up with all these other ones, okay? So what I do is I draw a generic triangle. Doesn't matter which way it's facing. I always get in the habit of drawing it this way. I also get in the habit of sticking the theta in the bottom corner, because in a word problem, if you are asked for the angle of elevation or the angle of depression, this is where that would be in your word problem. So I stick my theta there, and then I label the sides of my my triangle. Like if this is my theta, then that means this is the opposite. This, of course, is the hypotenuse because it's across from the 90. And then down here, the one touching it is the adjacent. And the reason that I do this is because now I just work backwards from what is given. So if they're telling me that the tangent is 5 over 6, and I look up here, and the tangent is the opposite over the adjacent, well, I just found out that the 5 must be the opposite side, and the 6 must be the adjacent side. So here's the 5 and here's the 6, okay? So if I know that, the way these things always work is you want to draw it out. Then step 2, you want to find the third side of the triangle. Now, y'all are not new to this, so I'm going to go fast through this. I mean, this is just a squared plus b squared equals c squared. And I'm going to find that side real quick. Is that a 61? Oh, this is a lovely problem. Okay, 61 does not have a square root, right? So it's just the square root of 61. And yes, it's ugly, but that is it, okay? And so you do this work to get to, be able to answer the question, because now it wants the other trig functions. It didn't just want draw a picture. It now wants the other trig function. So it wants to know, what is the cosine? What is the sine? We already know the tangent, so I'm not even going to write that. We need the secant, we need the cosecant, and we need the cotangent. Okay, so how are we going to get all of these? Well, look at your formulas, and we've already labeled our picture, so you're literally just grabbing these values. Cosine is supposed to be the adjacent over the hypotenuse, so it's going to be 6 over root 61. Now, I'm going to do a mini lesson now up here called rationalizing. This is something that you did, back in maybe Algebra 1 or Geometry. Rationalizing. Did I spell that right? I think I did. Okay, so a radical on the bottom is ugly. So even though this is the answer, it's an ugly answer, and if you want all of your points, you need to rationalize. And all that means is a trick to get the radical out of the denominator. That trick is just to take that radical and multiply the fraction by it over itself. And what always happens is it ends up, the top would just be this 6 root 61, and then on the bottom it cancels out the radical into a 61. So that would be my final pretty answer. If these two numbers had reduced, then I would reduce them, okay? But they didn't, so we're done. Okay, the sign. Now let's go a little quicker on the rest of these. The sign is the opposite over the hypotenuse, so it's 5 over root 61. And following the steps that we did above, that's going to end up turning it into that. Now secant, cosecant, and cotangent, don't think too hard on these, honestly. These are reciprocals, right, of the other ones. So if you know that secant is a reciprocal of cosine, then you just flip whatever you had for cosine. So I'm going to take this answer that I had already found, and I'm just going to flip it. So it's going to be root 61 over 6. The next one's the reciprocal of sine, so it's going to be root 61 over 5. And no rationalizing needs to be done on these because a radical on top is fine. Okay, so just leave those alone. And then the cotangent is just the reciprocal of what was given originally, which was the 5, 6. So notice not one time when I was down here, I did not come back and look at these. I really didn't because I don't need to. If I already have the other ones written, I can just flip them, do the reciprocal. Okay. All right, cool. So that is my advice for drawing the triangle, finding the third side, and using SOHCAHTOA, okay? Now, when do I use these, okay? Well, I'm going to use the other formulas anytime I'm given a problem and I can tell that it's maybe on the unit circle, or even if it's not on the unit circle, maybe it's just a point that was given to me, okay? So let's talk about that. So number one, let's do one from the unit circle. This is why your teacher is so like, you've got to memorize that circle. This is exactly why. Because if somebody comes along and says, okay, the cosine of something is the square root of 3 over 2. Okay, we could, and maybe they want you to do the same thing, find the other trig functions. Okay. We could do what we did on the last one. We really could. We could draw the triangle. We could label opposite, adjacent, hypotenuse. We can stick this somewhere. We can stick that somewhere. But there's a much faster way if you know the circle, okay? If you recognize that, oh my gosh, like that's one of my points on the unit circle. Like I have 3 points that I've memorized, and the square root of 3 over 2 shows up in 2 places. It shows up here, and then it shows up here. This is the point 1/2 comma root 3 over 2. So this right here, you know, it could go with 30 degrees. Now, why 30 degrees instead of 60 degrees? Well, remember, cosine, and you don't even have to remember, I've written it right up here. The word cosine, if you recognize, ooh, that's on the unit circle, then you can just think of this as the x. And then if it wants the other trig functions, then you're rolling with this column right over here. So if they wanted the sine, I'm like, oh, cool, I just need the y that goes with that. And the y that always goes with that is 1/2. If I need the tangent, then I'm just doing the y over the x. So here's my point that we were talking about. Y over x would be 1/2 over root 3 over 2. Now, a fraction over a fraction, I'll just tell you the riddle my 8th grade teacher told me. I've never forgotten it. Fraction over a fraction, don't ask why, just flip the second and multiply. One more time. When dividing fractions, don't ask why, just flip the second and multiply. So I just recopied the top, and then I flipped the bottom, and now I'm multiplying, okay? And when you do that, those two cancel, and I end up with 1 over root 3. Now remember from the last set of problems, a radical on bottom is bad. So here's our trick, top times top, bottom times bottom. So there would be your tangent, okay? And if you wanted to finish it out, the cosine is given here. So when I go to do secant, okay, if you want to look at your formula, you know, the secant's 1 over x, or if you know your formula, or you could just say, oh, okay, so it's just to take the cosine. If we're doing secant, it goes with cosine. Flip the cosine. So it's 2 over root 3 ugly answer, radical on bottom. Let me do my trick. And it would be that. Okay, cosecant, we're going to take the sine value and flip that. Now that was a 1/2, and when I flip that, it's just 2 over 1, or 2. And then cotangent was the x over the y. So now I take this one on top over the y. I'm going to do that same trick. When dividing fractions, don't ask why, just flip the second and multiply. Those are gone, and it's just √3. Now what's nifty about this is if you're in the middle right now of filling out a unit circle chart, all of your answers are going to look like this. Every single one of them that goes with a 30 or a 60. Now there's only two differences. They could be mixed up because between, like, these are all the answers for the 30-degree one. So anything over, what, 6? Anything over 6 is going to have these same numbers. It's just that some of them may be negative, and that's going to depend on what quadrant you're in, and you're going to have to think about, did you do x's or y's, and are they positive or negative? But if you're doing a 60-degree one, so like anything over 3, okay, it will be the same numbers. It's just that they'll all be flip-flopped or mixed up because the point is reversed, right? It's x comma y turns into y comma x, right? So it flips. Okay, so that's how I know. That's the only time I use these, okay, is when I know that I've been given a unit circle value over here. Of course, the other time I would use those is if somebody straight out said, what is the tangent of pi over 4? Well, if you recognize this is on the unit circle, that's another occasion where you'll be using one of those 6 formulas, okay? And you would have to just tell yourself, oh, okay, that's on the circle, tangent's y over x, and so the y at this point is √2 over 2. The x at this point is 2 over 2, and well, friends, that's the same thing over itself, so that's just going to be a big fat 1. So that's like an example of how you could do that, okay? And when do I use the formulas in the middle? I realize this is getting long, but if you've stuck with me this far, this won't take much longer. When do I get to use these in the middle? Okay, well, the answer is I don't use them a whole lot. Not gonna lie, I really don't. The only time that I use those is whenever someone's drawn a picture for me and it's a picture of a coordinate plane. Okay, so like if somebody has told me, ooh, still have erasing to do, sorry. Hold on, everyone. Apparently I'm British when I have to do the last set. Okay, so the there we go. So if somebody like has, you know, has drawn a coordinate plane for me, and then they're like, oh, hey, here's a point down here, and then they call it something, I don't even know, like maybe it's -6 comma -3, okay, and then they draw this, okay. If you see this and you're panicking and they're asking for the 6 trig functions, okay, do not panic. It's really not bad at all. You have choices. Oops, there we go. You have choices in different things you can do. This is an example, though, of where I use the formulas in the middle. And the reason for that is because my mind always sees, wherever this point is, I see that connection to the origin as the radius. Okay, because I kind of imagine, oh, there could be some kind of circle around this. Okay, that's like what my brain sees. And so when I see that, to me that's a radius. And then if this is my x and my y, you know, I think about, well, if I'm at the origin, how do I get to this point, x, y? Well, I go over 6 in the negative direction, and I go down 3 in the negative direction here, and that forms a right triangle. Okay, so this is my x, this is my y, and all I need is my r. So once again, you're doing a little Pythagorean theorem here. And was that 9 plus 36, r squared? Is that a 45? Okay, does that break down? I think it does. I think it's 3√5. Okay, so once we find whatever that radius is, now we can just use those formulas that are in green to do all of our 6 trig functions. Okay, so how do we do that? Well, I'm going to go fast because we've done a lot of this, and so this part should make sense. Okay, cosine x over r. X over r. The x is -6. The r is 3 root 5. Okay, that's an ugly answer. So I'm going to do two things. First, I'm going to reduce the 6 over 3. That's now a 2 over root 5, okay? Then I'm going to rationalize, so multiply it by root 5 over root 5, so this becomes -2 root 5 over 5. That would be my cosine answer. Sine, what do I do? Sine is the, what is sine? Y over r, so the y was -3, and the r was 3 root 5. Once again, cancel the 3's. And now multiply by root 5 over root 5. So -√5 over 5. Also, something I didn't say, the radius will always be positive because it's a radius, y'all. So when you draw it in yourself and you find it, don't be panicking like, oh, I'm in the third quadrant, maybe it's a negative radius. No, it's not. Radius is a distance, so it's positive, okay? But notice when I plug into these formulas over here, what am I doing? I mean, I am plugging in the negatives if they're there. So tangent is y over x, so the y is -3, the x is -6. That reduces to 1/2. And so I would then, you know, I could finish this, but I'm bored. So you would finish it by just doing these formulas instead and then calling it a day. Okay, I think that should help you guys out a lot with no matter how a problem is given to you. If you are asked to find the 6 trig functions or even just one of the trig functions, you can totally do it now. You're either drawing a triangle, or you're thinking of it on a circle and using these formulas, or it's a unit circle value and you don't have to draw any picture. You just pull from your memorized unit circle. Let me know if something else tricky comes along, and we'll talk to you later.